Hello everyone, let's go over modeling some radical equations. So we have a wrecking ball when suspended from a crane and models the movement of a pendulum. Pendulum is like something that, let's say, it's like this and it moves to the left to right, left to right, left to right. The relationship between r, the rate of speed of the ball, m, the mass of the ball, l, the length of the chain, and f, the force, is represented by of the equation r equals 2 pi radical ml over f. Determine f if l is equal to 12, m is equal to 80, r is equal to 0.5. We have to express our answer to the nearest tenth. So let's see. R is equals to, we know the value of r. We're going to substitute that with 0.5 is equals to 2 pi radical. M is 80, L is 12 over F. And I just use these specific numbers given to me already to substitute. Okay, we're going to do inverse operation. So first step is to divide by 2 pi, which is 0.5 over 2 pi is equals to 80 times 12. 80 times 12 we can put into the calculator and simplify that a little bit, which is 960 over F. Going to get rid of our radical by squaring it on both sides. And I'm not simplifying any of this information because they are going to give us a really long decimal, which I wait till I put into the calculator. Then I have 960 over F on its own. So I need to get the F by itself. So I can either multiply by F on both sides, or I can use the idea of product of means and extremes, which is something we learned in geometry, but if it's not as fresh in our mind, I am going to continue doing inverse operation. So F is equal to 960 divided by 0.5 over 2 pi square. And I know right now it seemed like, wow, what's going on? There's too much fraction, but we're going to do it with the help of our calculator. Okay, alpha y equal, enter, 960, and in the denominator we have another fraction, alpha y equal, which is, let's see, let me put a big parentheses around, and I'm going to put it exactly how I wrote it. 2 second caret gives us the pi, close parentheses, and exponent of 2, I come out, which gives us this really big number, but they wanted the answer in decimal, so x is 1597.12360 dot, we need to give it in nearest tenth, so we just need one spot, and that's it. That is our final answer. Let's take a look at the second question. The second question, I'm going to show you the full thing. There are two parts to it. Let's do it one part at a time. The first part says the speed of a tidal wave S in hundreds of miles, can be modeled by the equation S equal radical t minus 2t plus 6, where t represents the time from its origin in hours. Algebraically determine the time when S is equal to 0. So S is equal to 0. We need to figure out what t is equal to. And I'm going to do it by getting rid of this radical situation, which is negative 6 is equals to radical t plus 2t. Let's see. Let's keep doing inverse operation. Let's see where it takes us. Negative. They're not like terms, so wait. This was a minus already. So I would have to add the 2t. So 2t minus 6 is equals to radical t. We're going to do inverse operation to get rid of the root. We square That leads us to 2t minus 6 times 2t minus 6, which gives us 4t squared minus 12t. And then we have to do it one more time. 2t times 2t is, oh, this is a minus. I'm rushing, I need to slow down. That's where I'm making the mistakes. Okay, then we have minus 12t again, and then we have plus 36. Okay, 4t squared minus 36t plus 36. Okay, let's go. Nope, this is negative 24t. Okay, let's write it down. 4t squared minus 24t plus 36 is equal to just t. And if we want to make it into a quadratic equation, we need to make sure we set it equal to 0. Okay, now we need to factor it. I know it's a lot for this one problem. There's a lot going on. So we have to factor 4t minus 25t plus 36. So that one, we do that by multiplying my a times c value, which is 4 times 36, which is 144. And we have to add up to our b value, which is negative 25. I just go ahead and put it into the calculator and find out which ones multiplies, what are two numbers that multiplies to 144 and adds up to negative 25. In this one, it's going to be, both of the numbers have to be negative because they need to add up to multiply to a negative number and multiply to a positive number and add up to a negative. So let's see, we need a negative 25. It could be 9 and 16 might be. So 9 times 16 is 144. And they add up to a negative 25. So let's see. Bring down the 4t squared minus 9t minus 16t. Actually, I'm going to switch it around so then it will be actually nice to work with. 16t minus 9t plus 36 is equal to 0. And you could do that because in multiplication, the order doesn't matter. So now we pull out a GCF. 4t, then it becomes t minus 4, then minus 9. T minus 4 is equal to 0. 4t minus 9, and then we have t minus 4 is equal to 0. So which would mean t is equal to 0, and then t is equals to 9 over 4. We cannot stop there since it was technically a radical equation. We have to go back to the beginning, and we have to check for our answers. So we're going to do the check for t is equal to 9 over 4 and t is equal to 4. Let's see, let's do the 9 over 4 first. So 0 is equal to radical 9 over 4. Instead of radical t, radical 9 over 4. 2 times 9 over 4 plus 6. And I'm going to put it into the calculator, which gives me, let's see, second radical 9 divided by 4. Then we have minus 2 times 9 divided by 4. Then we have plus 6. That gives us a 3. 0 does not equal to 3. So this is extraneous root. Then we have to check for t is equal to 0. So let's see, 0 is equal to radical 0 minus 2 times 0 minus 6. So let's see. Oh, this is not 0. T should be equal to 4. 0 is equal to radical 4 minus 2 times 4 plus 6. Radical 4. Then we have minus 2 times 4. We have plus 6, which is equal to 0. Okay, so this works out. That would mean that there's only one solution. T is equal to 4. All right, let's take a look at the bottom portion. The bottom portion says, how much faster was the tidal wave traveling after 1 hour than 3 hours? So we have to find the difference to the nearest mile per hour. So that's our unit. So we have to find out what is S equal to when T is equal to 1 and T is equal to 3. So let's write down our final equation. Radical T minus 2T. Let me double check because I keep making mistakes on this one, so I have to make sure. So let's do it for 1, which is equals to 1. I'm going to put it straight into the calculator. 1 radical 1 minus 2 plus 6, that is a 5. And then let's take a look at the next one. S is equal to radical 3 minus 2 times radical 3 plus 6. This one I can't really simplify it nicely. It's going to give me a long decimal. Minus 2 times radical 3. We have plus 6. Yeah, this is a really long decimal. 4.2679. 49192, and we have to find the difference between them. And I'm going to go ahead and subtract them. 5 minus 4.2679, 49192, and that gives me let's see. Oh, this is not a radical 3. See, I knew today I'm rushing too much for this video. Okay, let's do it one more time. 3 minus 6 plus 6, which is just a radical 3. Okay, so I'm going to subtract these two. 5 minus radical 3 is equal to a 3.2679. 49192. Now this one, when they gave us the initial question, they said S is in hundreds of miles per hour. So this is hundreds of miles per hour. But the final one wanted in just miles per hour. So we're just going to multiply by 100. And that's going to move the decimal 2 units to the right for us, and that gives us a 326.7949 ... And let's see, did they want the answer? Oh, and they said nearest, so we have to round it to whole number, so which is approximately 327 miles per hour. Okay, jot down all the notes you see, and if you have any questions, you could bring it to class.